Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host as usual is Tobias Macey, and today I'm interviewing Vlad A. Ionescu about Earthly, a syntax and runtime for software builds to reduce friction between development and delivery. So Vlad, can you start by introducing yourself?
Yeah, sure. I'm the founder and creator of Earthly. I'm also the founder of Shift Left, a code analysis company. And before Shift Left, I've been at Google and at VMware as an engineer. And I've also worked on the early version of RabbitMQ in its early days.
Yeah, Rabbit's definitely a very interesting and ubiquitous project, although it is starting to be edged out by Kafka and Pulsar and the like.
That's right. It's been a decade since I worked on RabbitMQ, but those were really fun times for sure.
Absolutely, yeah. Erlang projects are always interesting in terms of just their resiliency and the locations where they get deployed.
Oh yeah. It's big in telco. They've always, prided themselves with creating the system that had 9 nines of reliability, which is like crazy talk these days, I guess. In many telco applications, that's actually required.
All right. And do you remember how you first got introduced to Python?
Yes. So Python for me was maybe my, third or fourth language I learned. So I was getting my first job in the UK. And basically, I was getting this job to pay my rent because I was a student. So I was living, in my student accommodation and doing this part-time thing while I was going to courses. But yeah, as I got this job, the boss there, the CTO of basically the company that created RabbitMQ, Matthias Reidstock, basically, he said I should learn more modern languages. So I was coming from a C++ background, and you can imagine, C++ is this old sort of thing that, by many standards, it's sort of, not as modern anymore. And that was when I started to look into Python, really try to understand it. And I did some tutorials, but no real work just yet. And a few years later, when I was trying to build my first startup ever, I picked up Python as I felt like it was just so easy to do everything. You can imagine coming from C++, having no libraries, no batteries included, nothing, all these like edge cases and bugs and, these difficult things to deal with that C++ makes you deal with, coming at Python and having, Django and all these really powerful web specific tools. I felt like I was, Superman, basically. So it was a really nice experience. Yeah, I've used Python on and off for the last, more than a decade now, I think. It's served me well in so many cases.
As you mentioned, you have a background in starting different companies, and the most recent one now is Earthly. And I'm wondering if you can describe a bit about what it is that you're building there and some of the story behind how it came to be and why this is the problem that you decided it's worth spending your time and energy on.
Yeah, absolutely. So Earthly is sort of the result of me having been a software engineer and not having the right tools for the job, right? And I've experienced how builds work at Google pretty early in my career. And I've seen how powerful a well-built build system and build automation system, really in general, how that can serve the engineering productivity. And as I came out of Google, I was just waiting for something to come in and give me those same benefits as I've seen in the internal systems at Google called Blaze internally. And I just couldn't believe for the longest time that Jenkins is the best the world can give us, Everyone was saying like open source is always the best and so on. But in the world of builds, it just wasn't the case. And later on, Google did open source their internal system Blaze, and outside of Google, it's called Bazel. But the pain with Bazel these days is that it requires you to take on this very different sort of alien world of tooling that the open source ecosystem isn't quite used to. You have to replace your Gradle scripts, your Python specific scripts and so on, and really buy into Gradle with everything that it has. And that is a big, big ask of the developer. So having those ideas, we thought about how we can bring some of the benefits of Bazel, like remote execution and high parallelism and high caching, bring those benefits without any of the drawbacks. So what that meant was you had to be able to use your existing scripts with Earthly, or you would be able to have all the sort of caching benefits that are similar to Bazel, and also have it be made very consistent so that when you run the system on one computer, it behaves exactly the same as you run it on another computer or when you run it in CI. And this is a property that we call repeatability. And it's sort of the core of our design process. This idea that no matter where you run the build, it'll behave the same. And that takes down collaboration barriers between teams. It takes down issues of works on my machine and so on. And also allows you to reproduce any failure that you might have in CI. So if anything fails in your CI and there's no way for it to reproduce it on your laptop, you're going to have a really long day. You're going to do git commit over and over again until you get that CI fixed. And if your build takes 40 minutes to build, which is not abnormal, it shouldn't be that long, but it's very common actually. You might be spending your every 30 minutes or so trying to get to that line that is failing over and over again and try to, throw other things at it. That can be a super time consuming process. And this ability to reproduce failures on your laptop is the number one thing that we're going for. And today is the number one reason people use Earthly for as it is right now.
And your mention of Bazel, and I know that there are other tools out there such as Buck, and the one that comes closest to home in terms of the Python community is Pants. And I'm wondering what your experience or thoughts are in the sort of relation of Pants to the kind of level of conformity that you need to bring to be able to make effective use of it versus the types of use cases that Earthly is well suited for, and what sort of coexistence you might find between those two tools.
I cannot speak for Pants specifically because I've not used it, so I'll put that out there. But in general, Bazel-like tools will have sort of the same, drawbacks. Of course, once you have adopted the system and it's working for you, you are now in heaven. Your productivity is, over the roof and so on. But the challenge for many of these systems is just adopting them. And we've also seen people use Bazel in conjunction with Earthly. And the reason they might do that is because there are certain things that you might have to do as part of the CI that Bazel doesn't quite let you to do. Or maybe they're just too difficult to achieve that way. And that's where you need some sort of system to allow you to put things together, like glue things together. And that's where Earthly is really great at. So if you wanted to have like Bazel or Pants based system, you can have that for specific languages. But once you have to write more scripts around them, for example, for releases, for maybe putting together other ecosystems that are not Bazel related or not Pants related, then maybe you need a glue layer. And Earthly in some cases is, really great as a glue layer.
And so digging more into the problems of software build and delivery, what are some of the core principles that you found that engineers should really be thinking about when they're designing that overall process and workflow, and some of the complexities that come about when they're dealing with figuring out, so I've got these, 5 files that do the thing that I want to do. I've got a basic web application. Now I need to get that into production. What are all the things that they need to be considering? And particularly as they evolve into more complex systems, how they're going to start encountering that incidental and evolutionary complexity of the system.
Yeah, where to begin, right? This is a pretty meaty topic. But I will say some of the design principles we've thought that are important are basically, that the team should be able to contribute to the build, the whole team, not just one or two people. And sometimes when the scripts give you too much freedom, like you have make files or bash files and so on, the more freedom you get, the more dangerous maybe the script feels. And I always say that, Bash is the only language that allows you to shoot yourself in both feet with a single bullet. But a lot of times people will feel uncomfortable contributing to those kinds of scripts because they're sort of dangerous. And so having a really easy to understand syntax, safe syntax that people can just dabble and play around with safely, I think is really important. The other principle, sort of designing for is the idea that you should be able to unblock your team very fast. So say you have a failure in your CI, and now maybe a significant part of your team is unproductive because maybe the integration test is not working, or something that they need to test out is sort of not easily accessible because there's this other blocker. And so optimizing for fixing CI issues, I think, is also a significant consideration to sort of take into account. And I think this goes back to that repeatability idea that I mentioned. But yeah, if you have a good way of quickly finding the root cause or reproducing it in an environment that you can control easily, that goes a long way to improving the MTTR of the CI.
Yeah, CI and CD is definitely a large and complex and constantly evolving topic. And I guess in that light, what are the components of the overall CI/CD process that Earthly is aiming to be part of or potentially replace?
Well, a lot of what CI entails these days relates to the experience in a web app, right? So a lot of the CI that you consume today is through a web app. And as we started Earthly, we've also thought about the idea, what if builds were more accessible from your terminal, right? That's where a lot of people work in, right? The place where they feel most at home and so on. And what would that mean, right? If everything was accessible through the terminal. And the things we address today are basically the process of you working with your code on your computer for the most part and iterating on your code in development. And then there's a part that we do, which is sitting on top of your existing CI and being able to run builds consistently for you. And so when it does fail in CI, there's a single command that you run on your computer that will reproduce that failure with a certain degree of consistency. Of course, CI/CD is broader than that. There's also a push into production and so on. One of the things we're seeing from our users, which is sort of strange but sort of natural, that we feel like it was bound to happen, and that is people are starting to use Earthly to push from their own computers, which is something you don't normally do. Like many people so far have been using CI to do pushes to production, mainly because of that guarantee of consistency, that there's that environment, there's nothing specific to the developer in that environment, and there's no surprising configuration that can, come up in that process. But because Earthly gives you that sort of layer of consistency, we're seeing people being comfortable with pushing from their own computer for that reason. So it's again the case that the developer's configuration doesn't influence the pipeline, and it's actually safe to do that. So, why not? It's just an implementation detail. The fact that it runs on your computer, you're getting the same effects, and that is, the consistency of the push. But yeah, we have plans for the future beyond what we do today. I'm not allowed to talk about everything that we'll do in the future, but just a hint for the audience, we're going to build something really exciting in this space. And we think it's going to be, the biggest shift in the industry since Jenkins. All I'm going to say about that topic for now.
Well, that's definitely quite the claim to make. So definitely excited to see how well you deliver on that. And going more into the kind of CI/CD question, there are a couple of interesting things to dig into, where one of the points that you mentioned is the risk of the developer's environment leaking into the build context, and how the CI framework or the CI execution environment is seen as this trusted location where everything is as it should be. And so that is what we're going to use to deliver into production. And then the other thing that you hinted at was the question of pipelining of builds and delivery. And so I'm interested in exploring what the capabilities of Earthly are in both of those regards, of being able to manage this isolated build environment so that you can be sure that there is this trusted execution. You don't have to worry about whatever version of Python or your environment variables or specific differences in the requirements file that might exist on your laptop. And then also the capability of being able to do pipelined builds of saying there are multiple stages to the execution that I need to make sure are run in this particular ordering, and how well Earthly is able to support those different concerns.
Yeah, exactly. So like you mentioned, every sort of automation system will come with its own sort of variance, right? And what we're doing with Earthly, we're trying to eliminate as much variance as possible. It's not 100%, deterministic, and I think that's an important distinction to make. We're not reproducible, we're just repeatable. We make that distinction because the output of Earthly will not be byte for byte exactly the same. There might be timestamps in there, there may be slight differences that are typically inconsequential. We made this deliberate choice of staying away from reproducibility in its pure form, or not staying away, but not enforcing it upon the user. And the main reason being that in order to make a bunch of traditional tooling work in that manner requires extra configuration or is just incompatible with that world. And so we did not want to limit the user. At the end of the day, the user needs to ship to production real apps. And sometimes in the real world, you make imperfect trade-offs in order to deliver on time and so on. But it does provide you with some level of consistency. And as far as we know, it's probably what most people need anyway. So what's the variance that we eliminate? We eliminate, for example, the flavor of the operating system or the dependencies you might have installed on your computer that maybe interact with the build or not, or any sort of programming language specific tooling, like which version of Python you might have installed, which version of PyPy, and so on. And then you might also have environment variables and local configuration and so on. We make that uniform across the different environments we run by containerizing the build, right? And so those factors that typically affect your build or create differences and prevent you from reproducing the failures in CI or the failure that another colleague is getting on their laptop, those differences are sort of flattened by the use of containers. And that's sort of the core of our design.
In terms of the challenges that folks run into when they're designing their build process, beyond just the variance in environments between the developer's local machine and the CI execution environment, what are some of the other complexities or sort of conceptual issues that folks run into, or just lack of education in terms of proper build and delivery, and any that are particularly relevant to the Python ecosystem? And then I guess the other question there is whether you found it to be mostly aligned along the language that these differences come about in terms of challenges versus the specific type of application, such as a web app versus a mobile app versus an embedded software device or a data science project and things like that.
Well, one category of issues is what I had mentioned, the ability of the team to contribute to the build process and not just one person. And we're seeing this over and over again in many teams, that there is this person that we call the build guru. And this is someone that wasn't actually hired to do builds necessarily, but for one reason or another, for in an ad hoc manner, they've just taken on this responsibility. And we're seeing this person put together the entire build, and because it becomes very complicated to achieve some of the same things you would achieve with Earthly, like containerizing your build, or maybe contributing across repositories and so on. Some of these things you have to sort of do in-house, and they get pretty fiddly with traditional technologies. And so that, again, sort of prevents other people from contributing to the build. It's just so difficult to understand. As another class of problems, it's not really Python specific, but we've seen that whenever multiple ecosystems come together, say it's a Python team working with a Java team or a Python team working with a JavaScript team, it's always hard to sort of build the other team's code and maybe put everything together in an integration test. And one of the reasons is that, you have to install the tooling, you have to configure it, and so on. Another reason is, the individual team members of each of these teams aren't familiar with that ecosystem. And so the simple thing of setting up your environment could take a whole day. And I think the worst part about bad builds the most common mistakes that happen aren't sort of what you might think, that there's something catastrophic that happens to production or something. I think, of course, it's bad to have an outage or two, and it could definitely be caused by builds. But I think for many teams, it's far worse to have a team that is not productive all the time than to have just a couple of outages here and there. And I think, builds that are difficult to contribute to, or builds that create barriers between teams, or not necessarily create, but like that's sort of the default mode of operation, right? Most language specific ecosystems will sort of encourage teams to use those language specific tools as well, which other teams will not be, familiar with. And so all of this combined will create barriers between teams. And, being a manager myself of engineering teams, I've always seen siloing or cross-team collaboration being sort of number one problem you have to sort of solve for and get everyone, working together. And, if you have a good tool to address that, I think that's a huge win for your team, for your productivity, for your organization.
Digging more into the Earthly project itself, I'm wondering if you can talk to some of the ways that it is designed and implemented and how you thought about the specific syntax for being able to provide the logic as to how these different builds should be executed.
So Earthly we describe it typically as sort of like Makefile and Dockerfile had a baby. So the syntax looks very familiar. We're sort of learning from the best things that Makefile and Dockerfiles gave to us, and taking some of the best ideas and hopefully none of the difficulties that sometimes come with Makefiles or any such technologies. As an example, I've worked with Makefiles a lot, and I've had teammates that for the longest time just didn't realize you have to put a tab in front of your recipe in Makefiles. That's such a small gotcha, and it's just a little example of how Makefiles can be pretty difficult to adopt, as a newcomer. And so we decided on this syntax. It reads kind of like English for the most part. We don't have like tricky symbols. If we do it, they're very well thought out. Of course, I'm biased. The idea is that everyone should be able to read the build file and contribute to it with ease. And if you're coming from Docker files, the syntax will look really, really familiar. We're basically extending that syntax and making it more powerful. So like with Docker files, you can only build, Docker images, but with Earthly, you can build not just images, you can run unit tests. So like execution that doesn't necessarily have an output, like an image or things like that. Or you can build binaries, you can build, regular files as artifacts, or you can push to production. These are sort of the typical things you might do with Earthly, and that's what we designed for. In terms of the implementation, we use BuildKit. This is a project created by the Docker team. They use it to power the way Docker files are built. This is the new generation of the build. Before that, I think it was called Docker Builder or something along those lines. The new generation is now parallel. It has really strong caching primitives like remote cache and shared caching. And you can basically use any Docker registry as a cache repository as well, among all kinds of really interesting features. But basically, we're using BuildKit as the execution engine under the hood. And really, we're creating a graph of the build with all the dependencies that go on between the different parts of the build, this direct acyclic graph, or DAG, if you will. And BuildKit figures out which parts can run in parallel, which parts cannot run in parallel. And of course, for many people who are familiar with Makefiles and the parallel option of, make minus J, they probably know that it's just so hard to get right that most people don't actually use that. And the reason is that Makefiles basically reuse the environment, the current directory, for every target that it runs, and they'll be stepping on each other's toes every time they would execute. Whereas with Earthly, it's kind of like you have every target in the Makefile containerized. And that way it's fully isolated from the outside world. And there's no way for it to interact with other targets unless you explicitly tell it to interact with that other target. Maybe there's an explicit dependency. One artifact needs to go from one target to another. But that sort of isolation frees up the system to automatically parallelize without any strings attached. And that is one of the benefits that Earthly provides, basically full parallelism as much as it can do based on the build graph, and giving that sort of speed benefit to the user. Underneath build kit, there are typical container primitives like runc and overlay fs, the file system that allows for sort of trees of files to be derived and extended while keeping the version of the initial tree. That is how Docker layer caching works, and that's what we also ported to Earthly as a primitive. Yeah, I think that's sort of high-level overview of how Earthly works under the hood.
So as you have been exploring the space of how to build the system that makes it easier to have a consistent environment for managing software builds, what are some of the early ideas or assumptions that you had that have been challenged or updated, and some of the ways that your exploration of the space has influenced the design of Earthly from when you first began?
Well, from the very beginning, we wanted it to be, very easy to adopt, and again, try to play into some of the existing knowledge of the typical user. So, like if you knew Docker files, Earthly would be a natural step forward, for example. Maybe over time, the one thing that we haven't really thought about from the beginning was the emergence of Apple Silicon and just the ARM architecture growing into a strong player, right? And so last year, the M1 laptops came out, and also AWS Graviton instances have been around for a while. For anyone who doesn't know this, AWS Graviton is the ARM specific line of compute that Amazon provides. And for many people, running on Graviton is just far cheaper because of the efficiency of the processor and so on. And so with the M1 laptops now, I think there's going to be a shift in the next decade or so, more towards ARM processing, or at the very least, a mix between Intel and ARM as sort of both of these working together in production. And not just in production, of course, you have to work together on the development computers. And so we've added support for multi-platform builds as a result. And many people use it today. It's super useful. You can basically build images that run either on ARM or Intel. The same image basically is packaged under the same Docker tag, goes in your registry, and you can use it on either platform. Or builds that basically build the same thing, but for your native environment. So maybe you run Intel in production, but if it's running Python, you can just run it natively on your ARM laptop and it'll behave the same. Or if for any reason you just cannot create the equivalent native execution of a certain process, you can still emulate it. And Earthly also provides this. Behind the scenes, we use QEMU. It's spelled QEMU. It's this emulation layer that can basically pretend like it's a different processor and run, binaries of a different processor. And that way you can have builds, for example, that, some parts build on Intel, some parts build on ARM, and then you can put it all together and it still makes sense. It still executes consistently across environments. That's probably the main thing that sort of we've designed into the system after the fact.
And another interesting aspect of the overall build and delivery question is what it is exactly that's being delivered, where in recent years a lot of that has become Docker containers, but there are also binary builds of a process, or you might be building a PEX archive of a Python project, or you might need to create a Debian package or what have you. And so I'm curious how the specifics of the actual output artifact influences the ways that somebody might use Earthly, or some of the ways that folks might need to think about the surrounding tooling that they're using to either scaffold Earthly or within the actual execution context that Earthly provides.
Yeah, exactly. Well, a lot of the modern workflows for pushing to production involve images, but that's not the whole story. Like every company somewhere will have some kind of package, some kind of artifact, or it could be intermediate files or files that are provided to AI and ML workloads, data files and so on. There's just so much else out there that just thinking that you ship images to production might not be complete. Or maybe it is true for your organization, but there's definitely some intermediate steps in there that you might want to really take into account. So yeah, you're right. I think beyond just images, you will have things that are specific to one use case or another in such categories. And one of the things that went into the design of Earthly was actually to support those use cases as well. There's always some file that has to go from one repo to another, and it's really difficult if it's not supported by some language ecosystem. For example, if you have protocol buffers, this format that allows you to serialize data between microservices or when you store them in the cloud or things like that. With protocol buffers, you have to generate language bindings for language that you use, right? So you might be generating language bindings for Python, but also for maybe Java if there is a Python process communicating with the Java process. And so those bindings are artifacts, right? And if those aren't treated like artifacts, it will become very difficult for each individual developer to get those or to refresh those, right? You have to install, Proto C, you have to install Python specific extensions and then Java specific extensions. All of these three things come from different package managers. And in fact, Proto C doesn't come from any package manager. Actually, you have to download it manually. And so these are sort of things that create that variance that we were talking about. You could be having a different Proto C version compared to your colleague. And now every time you run the build, maybe it shows up that you have differences in your generated code, but actually, that was not intended. Or it might just be very difficult for your colleagues to install all those little tools in order to contribute to the code base. So again, these are things you could wrap in Earthly or, something that basically creates consistently the same output and then reuse that output maybe across repositories. And for many traditional technologies, it's actually really hard to import things across repositories. Like you have to maybe create a package or upload it to S3 or just do Git clones on your own and sort of run the build on your own and have more scripting around that. That is painful, cumbersome, and leads to a lot of sort of human errors. You can get a lot of things wrong by doing that yourself. In Earthly, we provide that out of the box. Basically, you can reference any artifact from any repository and just import it automatically. Behind the scenes, it runs the build for that artifact and just provides it where you need it. And we've seen this being used over and over again, protocol buffers, especially for just about any sort of in-between sort of artifact that maybe it goes to production, maybe it doesn't, but you have to have it, in some integration test or you have to pass it along between projects. And it's really cumbersome when the language-specific ecosystem doesn't give you a way to do that.
In terms of the workflow of somebody who wants to adopt Earthly, particularly if they're working on a Python project for the sake of this audience, what is the process of starting to adopt Earthly and incorporating it into an existing application? And then once we've explored that, maybe what is involved in using it in a greenfield application where you're bootstrapping the whole build process with Earthly, and just some of the considerations in terms of the collaboration aspect of educating your team members on its use and adoption, and just some of the thoughts that go into actually making Earthly be a core part of your software delivery process.
Well, the first thing you can do is go through our onboarding tutorial, our getting started tutorial. And we have examples for Python that typically handles basically the typical sort of shape a Python project might have. Like maybe you have a requirements txt and you install dependencies and then you maybe package an app and put it in a container. If you're coming from Dockerfile, you might already have a Dockerfile that is executing the build for your Python image. You can reuse that in Earthly or copy paste and reshape it a little bit and it will just work. If for any reason you're not creating an image for production, again, Earthly is not just for images. You can still build Python packages that you maybe ship to another team or libraries that you reuse in another project. Those are things we support as well. That's sort of the way you typically get started with Earthly and Python.
For the case where maybe you're building a web application, so you have both Python dependencies and test execution, and maybe you want to package it up into a PEX archive so you have a single executable, and then you also have all of the JavaScript and CSS that go along with the web application that you need to compile through Webpack and Sass and whatever other tool chain you decide to use there. And then you want to either bundle that up all into a single final image so that everything's being served, with the static assets and API proxying through Nginx, or maybe you want to have two different artifacts where one goes to a Docker container running in a Kubernetes cluster and the other one goes up to some object storage for getting delivered via CDN. Yes, how do you think about designing the build process for all of those concerns?
So you might have this in multiple repos or in a larger monorepo, but what you would typically do is craft the build for each of these individual components. So, maybe it's something that processes your CSS. You put that process in a nerd file, for example, or maybe you have something that generates HTML that is ready to go to production. Put that process in a nerd file. Or maybe you have something that, I don't know, creates a Django app out of your Python. You put that as well in a nerd file. And then you might want for some of these things to sort of meet in the middle in an integration test. You can actually have an earth file that imports all of these results from all these three places and puts it all together in this integration test and executes maybe a battery of end-to-end tests on top of that. But also you might have things like, let's say, each of these individual components could be shipped to production either together or independently. So again, you might use the import mechanism to, again, sort of package everything together as a single unit. Or you might execute pushes independently for each of these components where, you push your, I don't know, CSS to S3 or, wherever Nginx gets its data from, or it packages a full Nginx image together with Nginx. So like the possibilities of composing builds are endless, and Earthly provides that, allows you to really go cross ecosystems. You go from the Nginx ecosystem to CSS to front end to JavaScript, Webpack, and Django and Python and so on. And because everything runs on Linux and everything in Earthly is containerized, it will work on Earthly and it will allow you to sort of compose these different processes, each of which are containerized and isolated and consistent, and then allow you to put them together for production use.
In terms of the sort of capabilities of Earthly, what are some of the things that you find people either most often overlook or misunderstand or don't execute to its fullest extent that you think are worth calling out?
I think many people don't use this cross-repository referencing as early as they could. I've seen people use Earthly for the consistency aspect of it, and then for one reason or another, we ended up telling them that this existed as a feature, the ability to import things across repositories. And it's actually really, really easy. And it works exactly the way you expect it to. You can pin it to tags and branches and things like that. Their mind is blown and they're already fans of Earthly, but now they like Earthly even more. So that is one feature that we've seen sort of surprise people, and is sort of this nice little surprise that they find out about later on. Another one is maybe the idea that as we build for different CIs out there, every script, every maybe YAML file or Jenkins file or what have you that is specific to your CI is just that. It's a script specific for your CI. So it doesn't work for anything else. And a lot of people I've seen migrate to Earth files, and then they realize they're no longer tied to their CI and they can migrate anywhere. It's this build that actually runs anywhere. And now that they are on Earth files, they've gotten new wings. They're now free to choose any other CI. And for reasons outside of the build itself, like, I don't know, the way the builds are hosted or the workers are hosted or the pricing or the way secrets are kept or any other sort of external feature could be reasons for which people actually switch CIs as a result as well. So this is sort of this vendor lock-in prevention is sort of another maybe surprising feature that Earthly gives you.
Your point of being agnostic to the CI framework or provider also brings up the interesting question of the Docker and Docker problem, where Earthly is using Docker for being able to containerize and execute these builds, but a lot of CI systems are actually also using Docker as their execution environment. And so I'm curious what types of challenges you've run into as to how to allow Earthly to work well within those systems where maybe you don't have the ability to run Earthly in privileged mode to actually execute Docker, and just some of the complexities that come up with this whole explosion of containerization as the de facto mode of execution.
We've gotten pretty good at supporting CIs, and there's some way to run Earthly in every CI. Maybe there's one that we haven't quite figured out yet, but we're working on it. It is Bamboo CI. It's not necessarily the most popular, but we anyway want to sort of cover the whole market. Docker in Docker itself has been an evolving thing, and most CI vendors are realizing that you're not just building Docker stuff in your CI, you're also running Docker stuff, which means you have to be able to run Docker for one reason or another, integration testing or whatnot. And so they've gotten much better at supporting it as a technology. In some cases where Docker in Docker is not supported, there's a way to use an external Docker daemon in such CIs, and that works just as well for Earthly. Yeah, it's a ongoing sort of battle with certain more obscure CIs, but there's only very few that we don't support.
Another interesting aspect of what you're doing at Earthly is that you're building a business around it, but it's also an open source project, which always brings up the question of governance and how you manage the project roadmap and how you think about the division of what is open source versus what is commercial and how to maintain that dividing line.
Yeah, I should maybe mention we are open, but we're not open source by the definition of the open source standard. The key difference that we prevent is a tech giant from copying us. And there are many reasons we do this, but the license we use makes the project become pure open source after 3 years. So that's sort of a balance between purity and allowing also us to guard our lunch, not leave anyone to eat our lunch. And I think that's a good sort of way to innovate on top of such a platform. But what we've seen in terms of what is open and what is not across maybe the different projects out there is there's typically some kind of barrier that sits between the open version and the commercial version. And that barrier is important to be a real barrier, not an artificially imposed one, right? So for example, a bad barrier could be number of users or something, right? That is something anyone could edit in the code out and say, users greater than one, just remove that line or something, right? So it has to be a real barrier that creates technical challenges of some sort. So for example, when you look at HashiCorp Vault as a product, the free version runs on one node at a time, one machine at a time. The commercial version runs either across a cluster or across multiple regions. And from an engineering standpoint, that's a clear barrier. There's a technical difficulty to making it work at scale. And in general, most projects that are successful commercially like that have this sort of natural barrier that makes it difficult to work with it at scale. Other examples are, Hadoop, which is like really, really hard to manage in production, to deploy, where the Confluent Kafka product, where Kafka is sort of this streaming service, of course, in sort of simplistic in terms of the way the primitives it provides, but again, it can be very tricky to manage in production, and that's where Confluent is helping companies do that better. We've seen this as a pattern. I think it's compared to the traditional days of when the only way to monetize open source was just providing services like Red Hat, consultancy and things like that. Those aren't quite as appealing to investors in Silicon Valley nowadays because the margins are pretty small. But this new model where the vendor hosts it for you and gives you extra scale, extra management, extra security, or something in that region seems to be working really well as a recipe for commercial open source.
In your work of building Earthly and working with the community of users and managing the business around it, what are some of the most interesting or innovative or unexpected ways that you've seen the Earthly project used?
We've seen Earthly used in just about anything. Like we've seen Earthly used in airport scanners, the things that check your luggages for, I guess, terrorist activity or trafficking of some sort. We've seen Earthly used in a lot of open source, like Jekyll, the framework that turns Markdown into HTML, or the Elixir Phoenix framework, the core framework of the Elixir language, or a bunch of other really interesting open source. We've also seen it in healthcare, in energy, high tech, low tech, just across the board. There's no like single type of company that sort of stands out as the typical user of Earthly. There's just across the board. And that is maybe one of the more surprising parts. We've sort of designed Earthly initially with a goal of making it great for the backend engineer, especially, but we're seeing it used in many other areas like embedded and front end and so on. Maybe we weren't quite planning, but we're just happy it's helping more people than we thought. That's probably the most surprising part.
In your experience of building the project and the business, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Well, I guess to some extent the industry already knew this, but we had to learn it, as we went along. But, languages in general are difficult to get right. It's always very tempting to just include every single feature that the community asks for. And in the process, as a byproduct, you're creating a language that is very difficult to understand by newcomers. And so over time, we had to sort of pace ourselves and really think deeply about every single thing that we add to the language to maybe not impose more difficult learning curve to the initial user while still providing all the capabilities that people need in order to achieve what they typically achieve through their CI, right? And so in that learning process, we came up with a bunch of principles that we use when we design every new feature at Earthly. And this was inspired actually by a talk by Brian Cantrell, the founder of Oxide Computer. This talk is about the platform values of Rust or something along those lines. And the argument that he made was basically, every value that you can come up with is important. And there's no question about that. Like, for example, you could imagine, what if your value was that your language was entertaining? Certainly that's maybe a goal for some people, like, some of, meme languages out there, or there are a few of these that are sort of made for that purpose. But really, all values are important. The important thing is which ones you prioritize for your own platform, because all of these are actually in tension and you have to prioritize ones over the others. And so he gave the example of C and C++, where C prioritized simplicity, whereas when C++ came out, it eliminated simplicity from its set of values and instead put in expressiveness. We can see now after the fact where that led us to, as the C++ language, and how that made things more complicated, more difficult to understand. And even though it feels like C++ is newer and more powerful than C because it can do more things with the syntax, it's actually, in many ways, it's also a step backwards, because now the language is less readable and it's harder to understand. There's some magic happening behind the scenes that means surprising, leads to a lot of bugs and so on. But this sort of tension between values is what prompted us to think about what our values should be. And we come up with these three. So number one for us is versatility. And that is the capability of the build system to achieve anything that the build system should, like every process you might have in your CI, including pushing to production and building binaries and running basically any sort of Linux specific executable and supporting those workflows fully. Our second value is approachability. So the approachability stands for the readability of the language, the friendliness to newcomers, and again goes back to that principle of every engineer on the team should be able to easily contribute to the build, and the language should be friendly and accessible enough for that to happen. And then number three is reproducibility, this idea of consistency. And of course, as we know, we're not fully reproducible like Bazel is, but we're striving towards that. And because of the ordering, we've put versatility in front of reproducibility, which means if there's a need to get some kind of software built, we will allow you to build it first and foremost, rather than make it difficult for you to adopt with Earthly, because we hold dear to this reproducibility value. This is where the prioritization comes along and is very important for us. The fact that it's first and foremost versatile and approachable trumps maybe all the pureness of reproducibility, yet we still provide you with as much what we call repeatability in exchange.
And for people who are interested in improving their ability to manage consistency between their development and build environments, and they want to optimize their overall delivery workflow, what are the cases where Earthly is the wrong choice and they might be better suited with one of these, monorepo build tools such as Pants, or using a different type of CI tooling or building their own homegrown system?
Today, we don't support mobile or Mac native or Windows native apps. Of course, we run on Mac and Windows, but we execute Docker workloads in there. And of course, if you've adopted Pants or Bazel, in many cases, you're just okay with that. You're already in the promised land, so to speak. You're getting the benefits of what we provide as well through those other tools. Of course, if you need to adopt them, that might be very difficult for you. And that is where maybe Earthly could be easier to implement in your system. Yeah, those are typical areas.
As you continue to build and iterate on Earthly, and I know that there are certain things that you're not at liberty to say, as you mentioned earlier, but what are some of the things you have planned for the near to medium term?
Yeah, so Earthly in its current form will always be free and open. Behind the scenes, we are working on a commercial offering of Earthly in the cloud. And again, I'm not allowed to talk too much about this, but it's something around builds, it's something around the cloud, and something that involves also artifacts and so on. It has a bunch of features that we've never seen as an industry before, any such product. And these features make the productivity of the developer so much more efficient than ever before. And we're going to launch this later this year. And we're really excited to have people on board try it out when we do.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose a book called Shape Up from some of the folks at Basecamp that talks about the ways that they think about the selection and execution of software projects. So it's definitely a very interesting approach. Builds a bit on some of the agile principles without being adherent to any of the more dogmatic formulations of it, such as Scrum or Kanban. So definitely worth taking a look at and considering how that project management approach might fit into your own workflows. And so with that, I'll pass it to you, Vlad. What do you have for picks this week?
Yeah, my pick is Andy Grove's book called High Output Management. If you're becoming a manager, coming from an engineering background, I think this will be a great book for you. This is how sort of I got introduced into management. It just opened my mind so much. It basically treats every management problem like an engineering problem for the most part, while educating you about sort of the motivation behind, the people's behaviors and how you can motivate your team and all that good stuff that comes with management. I've always quoted things from that book. Like ever since I read it, I always underline things in there. And yeah, it's such a sort of reference book for me.
All right. Well, thank you very much for that. I'll have to take a look. And thank you for taking the time today to join me and share the work that you've been doing at Earthly and your thoughts on the overall space of software build and delivery. It's definitely a very interesting and complex and constantly shifting domain. So I appreciate all of the time and energy that you've put into helping make it a bit more tractable. So thank you again for that. And I hope you enjoy the rest of your day.
Awesome. Thank you so much, Tobias. Thanks for having me.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.